Okay, so let's graph problem number 24. Let's go ahead and get our table of values going up. That's going to be too big. That ink is too much. It's overwhelming and not necessary. So here's our table of values. X, Y. All right, no talking. Don't make me call you out on this video because these videos are forever. Forever, ever. Okay, when it is, who asked me to do this problem? When it is not a logarithm, we start with the x's like we always have since we were little. The x values that we always will use for exponential functions will be -2, -1, 0, 1, and 2. Start with the parent function, y equals 2x. All right, start with that. So that means I'm literally doing 2 to the x power. So 2 squared, 2 to the 1 power, 2 to the 0 power, 2 to the -1 power, and 2 to the -2 power. I recommend starting from the bottom and working your way up. So that would be 4 and 2 and 1. The next two will just be the reciprocals of the bottom two. So this will be 1/2 and 1/4. So I got all those good y values. Okay? Now, right here on the chart, I would also do any vertical stretches or compressions. Basically, if there's a number in front, I would go ahead and make a new y column. So that's what I'm about to do right now. Because of that 2 in the front, I am going to make a new y column. All right. Notice this time I'm not doing anything with the -2 on the end. I will do that just directly on the graph. Since we're only going to have 4 function calculators, it's easier just to do it on the graph. So because of the 2 in front, that's why I'm doing 2y. So that's going to make this 2/4, which is 1/2. Okay, half of 2 is 1, and then 2 and 4 and 8. So that's my new y column. So I'm going to throw out the old y column, and I'm going to deal with this. Strauss, please don't talk during my video. So I've got these values. So this is the parent function. So I'm going to graph these right now, but I'm not going to connect them because this is not my final answer because we still have to do the -2. Don't forget that exponential functions start off with a horizontal asymptote, which is it will start at the x-axis being the asymptote. Okay, so here I go. -2, 1/2. Okay, so that's going to be right here. And then -1, 1. And 0, 2. 1, 4. And 2, 8. All right, Nate has a nice tune going, you guys. Oh, he can't even hear me because of this music. Question, go. Yeah, this is your problem, girl. It's all about you.
So, when we get to the -2, how do you distinguish between whether it's going to be moving up and down or left or right?
If it is, it's like this, all right? Say if I have 2 to the x power is a parent function. Okay, so here's 2 examples. In this case, the -2, this is going to be your down 2. All right, that's considered to be correct. That's considered to be outside the function. The inside the function that gives you the left-right motion, like you just said, when it's all up on the exponent, this would be, and you know how it's always opposite, so this would be right 2 in that case. Okay, so because of this -2, I'm going to move all of the 5 points down by 2. And by the way, that will affect the horizontal asymptote as well. So you should sketch your new horizontal asymptote at y equals -2. All right, and that will help guide you as you graph the rest of these points. So So I'm moving everything down 2. So I should have this, and this, and this, and this, and this. I moved everything down 2. Having different colors also helps. And that's basically it. So now I'm just going to draw the curve, respecting the asymptote. Don't cross over it. Okay, so your graph should look something like this. Now, in addition to this mess, they asked us to find the domain, the range, the intercepts, and the asymptote. So let's get that done. Okay, so here we go. The domain. The domain is going to be from negative infinity to positive infinity, because that's how far it goes from left to right. The range is from -2 to infinity. All right, range is from bottom to the top. So -2 to infinity. Notice my use of round parentheses instead of a square bracket. It doesn't reach the asymptote, so parentheses. Now we're supposed to do the intercepts. So let's do the X-Intercept. Let's see, is this something I can do super fast? I think I'll need to do the black screen on this because this might take a tiny bit of space. Black screen, yeah, that's what's up. It's about to get real. Let me just copy this down. So y equals 2 times 2 to the x power minus 2. That's a lot of 2's, I just realized that. Okay, so our goal right now is to find the X-Intercept. All right, the way you find the X-Intercept is by letting y equal 0. Okay, so that means I'm substituting 0 for y right here, which really means I'm just setting the entire equation equal to 0. Okay, so I'm set everything equal to 0. If I solve this, that'll be my X-Intercept. So algebra 1 step, I'm going to add 2 to both sides. So that'll be 2 times 2 to the x power is equal to 2. Now it's time to divide both sides by 2. All right, whatever you do, don't multiply these two together. All right, you can't multiply when there's an exponent. That's crazy. So those cancel each other out. And I have 2 to the x power is equal to 1. Oh, okay, I feel like an idiot now. So that's 0. That's 0, which means it was like on the graph the whole time. But a lot of times it's not like visible on the graph, so you have to go through these steps. But in this particular case, that was a waste of time because it's obviously right. It's always right. It's right there. We're looking right at it. Okay. Yeah, so 0, 0 is the X-intercept. Okay, we see it right there. Hold on, I still didn't do the y-intercept. Oh, well, that's going to be the same thing, 0, 0. And the asymptote, all right, oh look, it's all waiting there for me. Isn't that nice?